Hi, I'm Amy. In AP Calculus, there are two special trig limits you're expected to know and have memorized. Let's take a look at those now, and we'll do some problems relating to them. One of the special trig limits you're expected to have memorized for AP Calc is the limit as x goes to 0 of sine of x over x. If you try direct substitution, which you should always try first, you'll get sine of 0 over 0. And that's 0 over 0, which tells you nothing. The process of finding this actual limit by hand is a little bit more complicated than I'm going to go into in this video. But I'm going to show you graphically that this limit actually goes to 1. Here's a rough sketch of the graph of sine x over x. Now, as x approaches 0 from both sides, the graph is approaching 1 from both sides. The output value is approaching 1. There is a hole in the graph. The graph is undefined at x equals 0, which kind of makes sense since our denominator, as x goes to 0, our denominator goes to 0, which would make it undefined. But remember, a limit is asking you where is the graph heading, and this graph from both sides is heading towards y equals 1. The other trig limit you're expected to have memorized is this one, the limit as x goes to 0 of 1 minus cosine x over x. Starting with direct substitution and plugging in x equals 0, we would get 1 minus the cosine of 0, which is 1, in the numerator, and we'd have 0 in the denominator, and that's 0 over 0, which again tells us nothing. So we need to look at this function in a different way. Again, the proof of this function, a little bit more complicated than I want to go into on this video, but I'll show you graphically that this limit in fact goes to 0. Here's a rough sketch of that function. As x gets closer and closer to 0 from each side, where is the graph heading? The graph itself is heading towards 0. There is a hole there. Doesn't matter that there's a hole there. The limit still is going to 0. So now let's take a look at some typical problems you'll see on the AP exam. The first one says the limit as x goes to 0 of sine of 2x over 5x. First thing you always want to try is direct substitution, and of course plugging in a 0 here, we get sine of 0, which is 0, over 5 times 0, which is 0. 0 over 0 tells us nothing, so we need to try something else. Here's the limit we just learned about. Remember, x is going to 0, and the angle of the sine, x, matches exactly the denominator. So when we're looking at this limit here, limit as x goes to 0, I'm going to take this 5 and just pull it out in front. It's a constant, just kind of slide it to the side for a minute. We have sine of 2x over x. In order to make the angle match the denominator, I need a 2 down there. So what we can do is multiply by 1 in the form of 2 over 2. So I'll multiply by 2 on the top, and I'll multiply by 2 on the bottom, and now we have sine of 2x over 2x. That whole piece is equal to 1. What's left over then is a 2 on the top and a 5 on the bottom, making our final limit equivalent to 2/5. Let's take a look at the next problem. This time we have the limit as x goes to 0 once again. This time it's sine squared of x over x. We can rewrite that as sine of x times another sine of x, and that's all over x. So as you see limits as x goes to 0 and there's signs involved and x is on the bottom, you kind of want to look at them strategically and see if there's a way that you can use this particular limit. Of course, here we can see sine x over x, which automatically goes to 1. So then we're left with the limit as x goes to 0 of just a single sine x. Now we can try direct substitution. Sine of 0 is 0. So the whole limit is equivalent to 0. My final example involves the other limit that we were looking at. So this time we're looking at the limit as x goes to 0 of 1 minus cosine squared of x all over x. Again, direct substitution is going to get us 0 over 0, which tells us nothing. But we can use factoring here. Limit as x goes to 0. You may recognize that the numerator is a difference of squares, and it can be factored as 1 plus the cosine of x times 1 minus the cosine of x. And that's all over x. So you can recognize this piece right here, 1 minus cosine x over x. As x goes to 0, this whole piece goes to 0. So we have 1 plus cosine x times a 0. Doesn't matter what 1 plus cosine x goes to, this entire limit goes to 0.